Okay, so as we are discussing that the uh, the the frequency of letters, alphabets, they of in English text, they can be used to analyze the ciphertext and to convert the ciphertext into plain text, and to find out the key. So in order to avoid this problem, as we have discussed that up to now the substitution cipher that we are discussing, in this each plain text character, it is replaced by a fixed ciphertext character. For example, B is replaced by N, so everywhere B appears in the plain text, it is replaced by B. For example, by N, for example, B here, it is replaced by N, so B L here also is replaced by N, substituted by N. So in this way, so in this ciphertext, there is a problem that the analysis of the character or the alphabet analysis, it can be used to find out the key or to convert the ciphertext into plain text. To avoid this problem, so there is another technique which is called the mono. There is another technique, substitution technique, and this substitution technique, it basically avoid this problem. How it is avoided? For example, we have a key ACD, okay, and this is the plain text, Bob, I love you, LS. Okay, so in this this is called the pattern substitution technique. It is called substitution pattern and cycle. Okay, so in this technique, for example, we have ACD key. Okay, this is the plain text. This is one example. Okay, so ACD key, it is placed like ACD. Now again ACD, ACD, ACD. Okay, in each plain text position, it is added to the plain text position of cipher of the key. For example, B and A. Okay, so B position is second, 2, and A position is 1. Okay, so in this means that the B, it will be replaced by next character, next one character. So A position is 1, so the B will be replaced by next one position. Okay, so B is replaced by C. O is replaced by C position is third. Okay, so O will be replaced by third character. So the third next character is R. O, P, Q, R. So O is replaced by R. Similarly here, B will be replaced by the D position. So the D position is fourth. Okay, so B will be replaced by fourth position by B, C, D, E, F. Okay, so you can see that here the B is replaced by A and here B is replaced by F. So this will avoid the problem because B is replaced by C and B is replaced by F. So in this way, it basically hides the character distribution. So if this analysis cannot be applied here, this analysis, the character distribution analysis, it cannot be applied here. Why? Because here B is replaced by C and B is also replaced by F. So basically it hides the character distribution. Okay, so this is an example. Okay, this is called substitution pattern or in cycle pattern. Okay, now we are discussing that there we have several encryption algorithms. Okay, basically we have several type of encryption algorithm. Okay, and each encryption algorithm, it has its advantages and disadvantages. Okay, and these different encryption algorithms, they had different application and they were used, so different applications, they were using different algorithms. Okay, so then there is an organization, an US organization, which is called NIST. Okay, the NIST, they made a first attempt to standardize the symmetric encryption algorithm. What does it mean? They basically issue an open call for proposal, and they invited all encryption algorithms. Okay, so they invited all encryption algorithm, and then those encryption algorithm were analyzed based on their advantages, their disadvantages. Okay, so several algorithms were submitted and some of them were shortlisted. Okay, then among those shortlisted, one algorithm is selected, and that algorithm was called DIS. This algorithm, it was selected as a standard algorithm. Okay, so then this algorithm was used by each and every application on the internet. Okay, so this helps to standardize the encryption algorithm. So before this, different applications were using different encryption algorithm. Okay, so when this when the disk came, so it was standardized. So when after this, each and every application they were using disk. So you know that if a protocol or encryption algorithm become the standard, so basically it is analyzed from each and every perspective. Okay, and its whole working is available openly. Okay, so that's why this is the first step of standardization of encryption algorithm, and that was made by US department, which is called NIST. Okay, so what is called this and how it works? So let's discuss it. Okay, so this is called this algorithm. It is called data encryption standard. As I explained that it is US encryption standard, it was standardized, it was accepted by NIST. So I explained how it was. Basically before this, so each application was using its own encryption algorithm. Okay, so the NIST calls for all encryption algorithm. They are all invited, all of them were analyzed, and based on their weakness, their advantages, their disadvantages, their limitation, each and everything, and then some of the best one were shortlisted. Okay, among those shortlisted, the single one was accepted as a standard DIS. So it was used by each and every application. Then okay, so the DIS, it is a US encryption standard algorithm, and it was standardized in 1993. It has, as we have discussed, the symmetric encryption algorithm. It uses single key for encryption and single key for decryption. The same key is used for encryption and same key is used for decryption. So the symmetric key, the key that was used for encryption and decryption, it is 56 bit, and the text, it was divided into blocks, and each block was 64 bit. So on each 64 bit block, 56 bit symmetric key was applied. Okay, so if the text is more than 64 bits, then it is divided into 64 bit blocks, and each 64 bit block, it is basically encrypted by using 56 bit symmetric key. We will discuss its working later on. Okay, block, so it is basically block cipher. Why block cipher? Because the text, the plain text or the text, it is divided into 64 bit block. In each block, each 64 bit block, it is encrypted by using 56 bit symmetric key, and it is used with cipher block chaining. How secure is? So at that time when it was basically invented, that was very good. That was very good. So there it was thought that it will not be encrypted. It will not be so if a text is encrypted with the DIS algorithm, so it cannot be decrypted by the brute force attack. Okay, so but it was not basically, let me explain it first its example, then we will explain this statement through an example. So up to now we have discussed that this algorithm, it is a US encryption standard algorithm, and it is standardized in the 1993. Okay, so and this algorithm, it basically divides the plain text into 64 bit, and each 64 bit is basically encrypted by using 56-bit key. Okay, and it is symmetric algorithm. What does it mean? That the same key is used for encryption and the same key is used for decryption. Okay, so let's explain this through an example. So this is the working of this algorithm, that you know that the text, the plain text, it is divided into 64 bit. In each 64-bit block, it is encrypted by using 56-bit key. And the algorithm, it works like this way. There are 16 identical rounds. How much? How many? 16 identical rounds. Okay. So basically, initially, what we do in the first step, the 64-bit, the text is permutated. The text is permutation is applied. After permutation, in each round, after permutation, the text, okay, it is basically encrypted by using 48-bit of the key. Okay, so it is basically 56-bit key, but it is from 56-bit, 48-bit is derived, and this 48-bit, it is used to compute the ciphertext of a round. Okay, and then after this, again permutation is applied, and then again the text is the ciphertext is computed by using 48-bit key, and this is how it is generated. This 48-bit key is generated from 56-bit key. How it is done? Its working is, its detail is available in the RFC. Okay, so after 16 rounds, the final 64-bit output is produced. Okay, so basically this, when it was standardized, it was very good. It was very good, and it was thought that it could not be decrypted. It cannot be decrypted easily by an attacker. Okay, but what is Moore's law? Moore's law means that the processing power, it increases exponentially every year. Okay, so when the disk was standardized, at that time the processing power it was such that the disk was thought to be more secure, that given processing power at that time when the disk was standardized, so at that time the processing power that was available, according to that processing power, the disk cannot be decrypted by an attacker even in many years. Okay, but after this was standardized, the disk algorithm was standardized, the processing power increased, and the processing power becomes such that the processing power become so much that the disk was decrypted within a minute. For example, you can see that the disk algorithm, it was decrypted less than in a day. It was taking for an attacker to decrypt the disk algorithm in a day. Why? Because later on the processing power of computer, they become so much high that the disk algorithm, it could be decrypted by using the brute force attack by an attacker within a day. So it means that this algorithm becomes no more safe. No more safe. Okay, so and it was the not good analytic attack. For example, we said that it can be analytical. For example, the frequency key, it can be used. Okay, so in order to improve this, when the processing power becomes so large, okay, that this algorithm, it can be decrypted in a day. It can be decrypted by an attacker in a day. It takes a time a day, from many years to a day. So the attacker time to decrypt the key, the ciphertext of this algorithm, it from many years to just one day. Okay, so now to make the disk more secure, okay, then there were some efforts. The first effort was they invented double disk, because 56-bit key was not enough, so they used 2 keys, and that was also not become very secure. Then they used 3 disks, which is triple disk, which use 3 different keys. Okay, so this was thought that it could be more secure, because when the text is decrypted by using triple disk, okay, so the processing power, the given processing power, it can be used, but that will take so many years. Okay, so after this, when the processing power was increasing day by day, okay, and the disk algorithm, it was becoming not secure. It was not becoming secure. It can be decrypted by an attacker within a day, even if the attacker doesn't know the key. By applying all the keys, the attacker can decrypt the text of the disk algorithm within a day. So in order to cope with this problem, the NIST in the 2001 again make another encryption algorithm as a standard, and that was called AES. The AES algorithm, it was more secure than the disk. Why? Because it processed the data in 128-bit blocks. The disk algorithm, it was processing the data in 64-bit blocks. The disk algorithm, it was processing the data in 64-bit. Okay, but the AES, it is processing the plain text in 128-bit. What does it mean? That the plain text, it is divided by into 128 bits. Okay, and each 128 bit block, it is encrypted, and the key is increased from 56-bit to 128-bit. So the AES, it can be used by with the key of 128-bit, 192 or 256-bit. So by using the large size of key and large bit block, the AES algorithm, it is more secure. How secure? By using the brute force decryption algorithm, it will take 1 second on disk, but on the AES, it will take 149 trillion years. So it means that it is impossible to decrypt. Okay, so nowadays the AES algorithm is used. Okay, so now what are the main problem in symmetric key cryptography? As we have described that in symmetric key algorithm, the same key is used for encryption, and that key, the same key is also used for decryption. The single key is used for encryption and decryption. So it means that before secure communication between Alice and Bob, there must be a mechanism to securely exchange the key between Alice and Bob. Okay. So in the symmetric key cryptography, it requires the sender and receiver know shared secret key. Each Alice and Bob, they should know about the secret key, and it should be distributed securely. Okay. But now there is a problem. And what is the problem? That how to agree on the key on first phase. Okay, so the most secure method that was called physically, that the LS will physically share the key with the Bob. But this is sometimes impossible. Why impossible? For example, the LS is in Pakistan and the Bob is in US. So LS cannot go to US and then share the key with the Bob physically. So it is impossible. Okay, so they were using, so in practice nowadays we are using certification authority. These are the third party, the certification authority, these are the third parties. Okay, and they generate the key for a session between LS and Bob. When the LS and Bob they want to communicate, so they contact the certificate authority. The certification authority, it is trusted. It is thought that it is trusted because they are regulated by some authority. For example, you are sharing your data on Facebook, so you trust on Facebook that the Facebook will not share your data with anyone else. Okay, in the similar way, this certification authority, it is thought to be trusted. Okay, so when the LS and Bob they want to communicate, so LS and Bob, each and every user, they have a secure key from certification authority. So the LS and Bob they ask the certification authority for a key. Okay, and this certification authority, it distribute the key to LS and Bob. Okay, and then LS and Bob they can send the data to each other securely by encrypting the data with this secret key. Okay, but this certification authority is not 100% secure. Okay, so there is a possibility that, for example, the key is basically the attacker has gained access to the key. Okay, now the LS is starting that maybe the Bob has shared the key, and the Bob is thinking that the LS has shared the key. Okay, and there is also a possibility that the certification authority has shared the key. Okay, so in the case that the key is basically if the key is known to attacker, so there is no accountability, there is no mechanism to fix the accountability that who has shared the key, because the certification authority, it can say that okay, I didn't share the key, it is shared by LS, and the LS can thought that it is shared by Bob, the Bob can thought that it is shared by certification authority or LS. So there is no mechanism to fix the accountability that who has shared the key. So this is a big problem in the symmetric key encryption algorithm. What is the problem? The secure exchange of the key. And why? And in the case the key is come to know is basically if the attacker comes to know about the secret key, so there is no accountability mechanism to fix that who has basically shared the key with the attacker. Okay, either the certification authority, either the LS, either the Bob. Okay, for example, if the Facebook it say that they are attacked, and maybe the Facebook has voluntarily intentionally shared your data with someone else. Okay, so you cannot have any mechanism there to prove it. Okay, the accountability. So similarly, I can give you an example from practical life that when you generate your PIN number for ATM, is it 100% secure? No. Why? Because you activate it through a call, through a phone call, and the phone call, for example, you are activating through a U-phone. So the U-phone, they know about each and every of your conversation, and even they can know about your PIN number. Okay, so this was a big problem in the symmetric key. The first problem was how to securely distribute the key. this is a this is a very important topic, and many research papers are proposed, many algorithms are proposed, but still they are not 100% secure. And the second problem is when the key, the secret key is basically when the attacker comes to know about the secret key, so there is no mechanism that who has shared the key with the attacker, who is responsible, whether the certification authority, LS or Bob. So there is no mechanism to fix the responsibility. So this was the big disadvantage of symmetric key, although it is computationally less expensive. Okay, now how to solve this problem, that there should be no exchange of secret key. Okay, so this problem again, it was solved by a public key cryptography. So the public key cryptography, it basically avoids the secure sharing of secret key and symmetric encryption. So the public key cryptography algorithm is proposed. So the public key cryptography, there is no need to securely exchange the key. To secure exchange of the key is not necessary. And second, it also has the mechanism to fix the responsibility in case the key is shared with the attacker. So there is in the public key algorithm, there is a mechanism to fix the responsibility, that who has shared the key, who is responsible for sharing the key with unauthorized person, with an attacker. Okay, so in the next class we will discuss the public key cryptography in detail.